If I wanted to close this library with a clickbait, I would probably go with something like, I've spent 3 years building the best possible library to create and consume REST APIs, and here what I've got. And this would be true because now I'm going to talk about ReScript Rest library I've built, and also the whole toolchain around this, which helped and made this library possible. And yeah, the library really got the first information and the first ideas about the API something like 3 years ago. It's actually just 2 months till this. It's like 2 months less than 3 years, frankly speaking. But I have to admit that the library is unique, and I'm going to show you all the features it has and how simple it is, and how simple the API and how powerful it is. And yes, so talking about this video, the plan is that we are going to create a simple ReScript application, and you probably could have guessed, looking at a lot of ReScript libraries in my profile, that this is going to be related to ReScript. But I have to note that this is not only a ReScript library, even though currently it is, but for example, I have ReScript schema, which works for both JavaScript, TypeScript, and ReScript. And also there are plans for this ReScript Rest library also be TypeScript friendly. And you probably might guess why I want to port this for TypeScript, because there are a lot of similar libraries like trpc. You could heard of this, it's the big name. Also there is tsRest, Hono.js recently released their RPC like client, and also you could have just used something like Fastify or Express. But the answer is simple, because as I said in the beginning, this is really the best possible API in my opinion, and I hope you'll agree with me. And yeah, I think it's really amazing with ReScript, and it will be similarly amazing with TypeScript without alternatives on the so-called market. So the plan for the video, uh, going back to this plan, we are going to build now a simple ReScript application. This is going to be a REST server where we are going to have simple a few routes to, for example, let's use posts as an example. I didn't really thought through the logic yet, but we are not going to concentrate about database. I know that Gabriel have a really amazing tool to work with Postgres, but we are just going to focus mostly on the REST itself and the server-client interaction. So we are going to build this. Then we are going to create a simple client to show how nicely and how simple it is, and how type system helps you with building. Yeah, I think the best case and the best help of the type system, it just helps you to build and don't hinder you with this. And I think it will be a nice addition to show that you can actually create and generate OpenAPI with few lines of code, and also host it with Scala. Also, it's not so difficult to add support for Swagger UI, but I just think that Scala is a modern solution, so it's just goes out of the box. So we can take a look at this nice open API documentation tool. And I think it would be also interesting to include comparison of ReScript Rest and like other libraries I mentioned, trpc and tsRest, and showing why ReScript Rest is superb. But I think it will be better to put it into another video and instead spend a little bit more time going into more details and write a little bit of tests, like unit tests for for our server. Also write some integration tests and just show a simple way how you can add authentication, and just like not the end-to-end example, but some primitives which you can use to start building. And then I'll probably record another video where I go into more details with this. So let's start with create ReScript app. Okay, let's go. I didn't prepare beforehand and we are going to do this live, and I'm not 100% sure that it's going to be a success. So let's check my memories and how to start a ReScript project. Didn't do this in a while in this way. So probably we can do this by running npm create ReScript app, and let's add latest at the end just in case I have ReScript app installed. Okay, let's click yes. So I didn't go through the flow for quite some time, and yeah, I think I didn't use the latest version yet. So what's the name of our ReScript project? Let's call it ReScript Rest demo. What template we want? Probably basic, just command line is enough. Let's use latest 11 version. Let's use latest core version, and we are done. So I think now we can open it by entering ReScript Rest demo, and here it is. So give me some time to put the windows nicely. Okay, we are here, so let's take a look. We have our ReScript JSON file with all the configuration for ReScript compiler. Super nice, it has ReScript core already here. The README, let's rename the build and watch script because this is more convenient for me to run it when it's called like this. And the demo file. As I said before, I think it makes sense to have some logic when I show you the API as a library, so it's more interesting to interact with some data that changes for mocks, and I think it makes sense to do it properly. So I think if you have an entity, it's good to create a module for this, and idiomatic in ReScript is to call the type of the main type of the module with letter C, so it's easier and more conveniently to reference from other modules. And for posts, let's have a few fields, for example, ID, title, body, and I want to have some non-string fields for to make it more interesting. So let's add public, won't have age restriction, and what else do we have? Views. Nice. Okay, views, it's going to be a little bit more complicated because then we are going to have different... okay, it's fine. So we have posts like this, and after this we need to, if you want to create a backend for this, we need to define some roads, how our API will look like. So for this, I'm going to create a new file called, I clicked in the wrong place, called contract. And in the meantime, I will delete the demo file because we don't need it. So let's think which roads we need. And I think it makes sense to start with a road called create post. And here we are going to use the library ReScript Rest. And to do this, we need to install it. So we need to install actually two libraries, both ReScript Rest and ReScript Schema, which is the core of everything and which will allow us to define the schema for our road. So we need to write them in the terminal. The first one ReScript Rest and another one is ReScript Schema. Looks correct. So let's wait when they are installed. And yeah, it's done. And so now we need to connect them in the ReScript config, ReScript Rest, ReScript Schema. I use supermount, so it helps me. And also we need to open ReScript Schema here because it's namespace in case you want to override it. And we also need to restart the compiler. So now it's done, and we can continue with creating the road. I've hidden the left tab so it doesn't take much space. Also need to reload the window so it updates modules it can autocomplete. And we use the module REST coming with ReScript Rest and create a road. Road accepts the single argument which is a function, and inside of it we can start writing the definition. So the first one, method. I think method makes sense to have it as a post. Path is going to be, let's have it posts. Also what we can have, we can also add a description, and this is not mandatory, but this is going to be a good addition if you are going to use OpenAPI generation. So this is going to be referenced there. And now we also need to add variables which this road is going to be accept. So some sort of request definition. And for this, we need to add the variables field which accepts this as context argument. So now we can describe what variables of the create post road are going to be. And I think to make sense for the create operation is to pass title and body. So let's have it here. And title is going to be a field title, which is a string, and body is going to be field body. That's all, and it complains about, let's hover it, and says that responses field is missing. So let's also add some empty responses for now. And it complains, the type system complains. Actually, it would also complain in runtime because responses can be empty. And let's add a single response that it returns nothing for now. And let me explain what's going on with variables here. So, okay, let's to show you how what variables are. Actually, let's hover over the ReScript Rest. It's instance of the row type which have two type arguments. The first one is the type of variables. It's kind of the input of our road and a response. So currently we have an input type, this object with body and title, and the output type is unit. So for example, what we can do with this now, we can get this road and we can call rest fetch. Here we provide the path to where we are going to fetch this, and then the second argument are the variables, and here we are going to get a response. Oh wait, so if we have our response, it's going to be the response type, and for example, if we decide to change the title to int, it will complain that this is doesn't match the variable's type, so title should be int now. And also we can change the response and say that, for example, we expect response to be return a field post, which is also a string. So now it will correlate here that response is a string. But so I think it's nice how the variables types and our output response types are related. And I'm going to show more later what we can do with this, but I think let's just finish the most simple rote implementation, like make it completely correct. And to do this, actually, this is not entirely correct here, that responses return post, which is a string. They should return a proper post. And to do this, we can use ReScript schema. And we need to actually create a ReScript schema for the post. And one way is to use ppx, but I think let's do this in a more basic way, because ppx's have some limitations. So let's just build the schema by hand. And to do this, we need to, we can, like, there are two ways how to create a schema for an object. The one is to use as object, and it's like more advanced, which allows you to add some data transformations and also renames the fields. But I think the as schema is the most convenient way to create a new schema. So here what we can do now is, let's enter all this. Okay, let's select all these parts, copy them and add this matches as. So ReScript schema have a similar API to the ReScript type, so it's quite easy to create a schema. This is enough, and what's amazing about this is that it works in two ways, so we can both decode and encode using this one. And also what we can do, we can provide it here. So now if we have our response, we can see that it expects to return the post, which is nice. But let's go back a little bit to this rote definition, and you probably can notice that I use this as field, and it's like, what's going on here? I should probably, let me think how I should explain this. So in this, let's take a look at the response definition. There are two things going. First of all, we describe how the response should look like on the HTTP level, how it's transferred. And what it means that if we use the field post, it's going to be a respond with application JSON type, and also content type, and also is going to have a JSON body with the field post, which will contain the data of this post schema. But we can also, instead of putting it in the post field, we can change this and directly say that we want to directly return this post schema as the body like of our JSON. Also, it's cool. Let's say that we want to say that, okay, we return this post schema as the body of our response. So like in the HTTP level, it will be just this object sent, but we actually on the ReScript side where we use this, we can change this to be some other data structure. For example, on the ReScript side, it might be an object with the field post. So here we will receive this object, but it will be sent as like without this post field. Also, we can add, let's add something interesting. For example, views. And the views, we can also add a special field for this, will be sent in a field views, which is an int. So it's like super flexible. So this is like this post and views field are going to be merged in the JSON, but then when we receive them on the fetch call, they are going to be then transformed into two separate objects, like one post object and one views int field. But what's even more exciting is that you can even, instead of adding it to a field, you can use this as header and, for example, usually just added X because usually custom headers are prefixed with X, but you don't need this. So in this case, you'll be able to get your views in the response, but in actual like transport level, they will be sent as a header. So this is super flexible. Also, what we can do, let's remove all the unnecessary things. We can also add a status here saying that this response should be returned with the status 200, and when we call this REST fetch, we expect this schema be sent with the status 200, and it's like the data is validated. And don't worry about the runtime validations because ReScript Rest is super fast, and really it's like the fastest library existing. And yeah, a little bit lost my thought here, but I think you can get an idea. And why you want to need to provide a status, because for example you might have we can actually use the ReScript type here, and we might have an error return here, and let's say that an unexpected error, and it's, for example, it's going to contain this unexpected error, and it complains because I should also wrap the data in the in OK. And now we can see that our response is wrapped in result, but like how should like how it works in reality, because like this looks a little bit magical, but what this definition means is, for example, if received a response from the server with status 200, we are going to try to parse the JSON body with this post schema, and then it's going to be transformed into the OK post type. But if we received any other status by default, if there are no explicit status definition, it's going to catch all other statuses, or default. If we talk in the OpenAPI terms, is going to return as this error unexpected. error variant. Also, we can make it a little bit more interesting and return, make the message dynamic. So, for example, on the server, we'll be able to provide a string, like a plain string, and it will send it as a JSON body with the message field. And also we can, for example, say that is going to be status 400. Okay, I think let's keep it as it is. And because now I'm showing you mostly examples on how to consume this, but I think it will be interesting to switch to how to create the implementation for this road. And yeah, I think I can mention other things about this role definition and other abilities, because you can see that this S context contains many things like field body, row body, header, query, param, aus. So you can really structure and describe how the transport layer will look like in a super type safe way, and then get this variables and response type arguments in a convenient way to consume on the ReScript side when you call this road from the client or when you implement this road on the server. Whew. So many things to explain. I didn't expect this because this was very, very obvious for me and natural. But that's not the end. Let's continue building. Just check the time, 30 minutes gone. And how to... Okay, now it's better. Now let's create our backend. And not like, even though I've put this call example in this current file, let's keep this. For now, let's start with building the backend. Okay, I'll do it in a good way. So I'll create a separate module called server, and I'll work in it. So to create a server, there is ReScript Rest comes with binding for Fastify and a nice integration with Fastify. So what we do, we call Fastify, make, and we are done here. And then we can call Fastify road and pass our contract create post road, and then the second argument is an implementation. So if you take a look at the definition of the road function, it accepts the Fastify application, and then the second argument is our road with request response, and the third argument is a function which accepts requests and returns a promise, a response for obtained promise. So it's super nice. So here we already have a type error because it's type safe and it's nice, and because we return unit instead of result post. But let's silence the error and just return an error saying that it's not implemented. TypeScript, ReScript don't helps me with, okay, I think I can't help the, yeah, I can help the formatting with the explicit brackets here. So we have variables, and in variables we contain, like, variables contain, it shows me, so variables do contain this object, body and title. And why I like to use object instead of a record here is because we don't need to defined a type for the data, which is not really some entity or something like this. It's just some random data. So it's just part of the fields we need to create the post. And yeah, we have our road, and I think this is good enough implementation for now. So let's do the final thing and call Fastify listen 3000, and it doesn't work because we need to pass the port like this 3000, and also need to await. Okay, why does it complain? It returns a string, and what the string is, I don't remember what the string is. So let's also, I think it's URL. So live on live at like this, and it's done. So the question is how we run this server so we can test that it works. And also let's move the call here and just keep it in this file. So when we start the server, we do this call and check what it returns and like verify that it works. So it's difficult for me to type and type without typos and speak at the same time, but I think we are doing pretty well. So let's also log response here, and let's add some title so we know what it is. So we have working Fastify server without caring about all this, like what request, what response, like what status we should send. We just get variables. It's already this data what we want, and return a result type with simple post string. And we don't need to care whether it's sent back with a status 200, whether it's sent back with a status 400, or maybe it's sent using a header or query string or pass param, or like just we don't care how it's sent, like in which JSON structure. We just connect the road and add implementation here. So this is nice, and what's left is just to run our server. So since I'm going to run this multiple times, I'm going to go to package.json and let's create a script server, because later I plan to add here a script called a client, and I think it's almost correct, like this. So now let's go back to the code, and here let's expand the terminal and run server. Okay, I actually found an issue here. Okay, I started debugging and I just realized that I'm stupid and we need to install Fastify. It's an optional pure dependency of ReScript Rest, so it's not included if you want to use ReScript Rest only on the client, but you need to install it separately if you want to use it on the server. And yeah, all of this written in the ReScript Rest documentation. So if you have any problem, I recommend you to read this. And if you don't have any problem, just read this, because you might probably you'll find some interesting insights onto how to build and how to use this tool. So let's clear this and run server again and hope that it will work. And it is. So we are live on localhost 3000, we got log of the, this log is from the server, and this is a response where we get an error not implemented, which is amazing. And do you know how it was sent? I don't know. And we we can check this in the in the row definition, because it's described here. But if you're interested more in details, or you want to patch something, there is a way to pass a custom feature which accepts some args. Okay. Let's just try to log and see how it looks like. So you have the default API feature which built on top of the build, on top of the fetch. I'm already confused words here. And let's see what our feature args are on the server. And the feature args are actually the body, which is a JSON string like this, a header, which is a content type application JSON, method post, path to the localhost 3000 posts, and that's all. So let's remove other logs and just add a few more experiments. Actually, we can use this URL to pass to this fetch to make it even more nicely. And let's go to the contract and do what I've described you before. So for example, here we are going to have post schema posts. Okay, we are not going to see this because we are returning error, but never mind. Let's say, for example, we want to return this title, send this title as a header, and the body, for example, is going to be a query string. And let's also add something else. So field 1 int. Also, you can send field 2, which is bool, which we can also send the whole body object, which is, for example, okay, let's create just some simple literal with test. Why does it complain? Okay, I just started overcomplicating too much. And also what's cool here, we can also add ID, and it's going to be path param, ID, and for example, param can also be bool here, or let's do it in something more interesting. Okay, bool is fine. So when we call the API here, we can see that it immediately started complaining. What it expects. Let's copy the type here. We can comment this out and add some string here, int1, int2, ID true, and title. So does it compile? Why is it incompatible? Okay. Field 2 is a boolean, and why is it? Okay, because I turned it to be a boolean. And if we call the function in the feature args, you can see that, okay, now we have a body, which is 2 fields, 1 and 2. We have a header. Now it contains a header title. Also, our path became even more interesting and complicated. It's posts where the second param is true. It's automatically converts all the types to string. So on the ReScript side, we have it as a Boolean, but like here when we call the fetch, and also here when we use the fetch, but it automatically converts to string when we have a pass, and also we have a query string param, which is a full string. So I think this is amazing, and this shows enough of powers of the ReScript Rest row definitions. Let's roll back everything back because logic previously was kind of sane. Not like this, not like it currently after my changes. Yeah, looks good. And let's also remove this. And let's just call it, yeah, it works without any errors. Nice. So what it is now, it's time to write some logic and create something meaningful with this. I think recording long videos is my destiny because the second video I record is already 50 minutes almost. But, well, there are so many things I want to share with you. And yeah, let's start with simple implementation. And here's our server. Let's simply create the posts, mocked posts array, and it doesn't know what are the posts. ReScript complains, and this is because we don't use it yet, and it doesn't know what are inside of the array. But I think that's not a problem. Let's after we continue writing the code, it will automatically resolve itself. So we create a new post and an ID. What should be an ID? I think we can keep it simple and use length of the mocked post, convert it to string, and yeah, length is good. So we have ID and it doesn't know what's going on because post type is another module and we need to add it here so it helps us. And what else? We have titles, get it from variables, public. Let's have it false by default and we use 0. Nice, we've got our post. Then let's add it to our imaginary database, if I can call it like this, and we can return it to user. We are done. I think this is amazing. Just so simple. And let's see where we have logs, and let's uncomment this response log and run the server. And we can see that we still log feature args, where we send this title and body in the body as a JSON, and received the response where tag is OK. And here's our post object, which is nice. So I think we can consider our server implementation done. But what I want to show you here is that we have validation out of the box. So for example, let's say someone wants to, someone doesn't use our typesafe ReScript client and calls just from outside of the world and sends, for example, instead of the title, some integer. And if we run this, we'll get a response saying, okay, we got an error, and an error says that failed parsing at body title. So we failed parsing body the field title, and reason that we expected a string received 1, 2, 3, which is set. So nice validation. And also another thing that, for example, they set extra bad field, and by default, as any other library, parsing validation library, it just simply strips it. But what's cool here is that we use ReScript schema, and ReScript schema as ReScript Rest has a bunch of cool features unique to this library. So what we can do, we can add this call this set global config and say that default unknown keys should be strict. We have two options, either stripped unknown keys or fail when we get unknown key. So we say that it's going to be strict. And also there are some other options. For example, we want to do some optimizations, and for example, we know that all the data comes from the like it's serialized from JSON, so it's not going to be none. So we can also improve performance. It's actually a tiny improvement. We can disable the none check. And if you're interested about this validation performance, go check out the ReScript schema documentation. I'll of course leave all links in the description, and you can find the benchmark there and see that it's the fastest. So let's quickly build something production ready looking like, because we spent quite some time looking at the ReScript Rest API and playing around with it. So the first thing I'd like to do is to actually move this fetch call to the separate module client that's created. And that's because we have usually two different environments where we create the API and then call it. This is not going to be used anymore. And why I also want to split them, and why I have the contract in a separate file and server and client in other separate files, is because they usually run in different environments, and this is going to be on the server environment, and this is going to be on the client-side environment, like for example some front-end application. So they're going to be executed in like separately. Also they're going to have different environment variables, so we don't want to share some, for example, we don't want to server code leak to the front end. Hence we have this contract definition in a separate module. And what's cool about the contract definition, if we take a look at the generated code, this create post, actually it's just a function, like it's a simple function. And why I so excited about this, because if you have a simple function, and for example you have 20 different roads here, you use only 2 of the roads on for example Next.js application page. This is going to be tree-shaked because functions are tree-shaked well, and it won't add dependencies to other roads to your bundle. Also all the dependencies to the schemas used for some roads you don't need, and which are not used in your road. So it's like really great thing that this is compiled to a simple function. So here now when we have a separate environment, the question is like, where is the URL coming from? And of course we can simply write HTTP localhost, and let's check that it works. So we add client here. Let's run. So we need to run server first, and also how to create a new one. No, not this one. Okay, I've done this. And if you run client, we can see that it works. But this is not what we want. So usually in real applications, we get this API endpoint from the environment variables. And how do we get environment variables from in ReScript? The simplest way is to call row process.env.api URL, and if we run our script, let's actually add it here with this environment variable, we can see that it still works. But I don't really like this. Like, it's fine when there is only one place, but it actually might break super fast. For example, if we forget to add this, it's like not obvious when we forgotten to add some environment variables, and in this case it's quite obvious that we didn't add this API URL, but usually it's not. So for this, I usually solve this problem by using another library called ReScript and safe, and this is also built by me. So if you remember, if you remember this page, like, I have a lot of tools built for ReScript, and they are tightly integrated with each other, and one of them is this ReScript and safe. Also recommend checking out the docs, and yeah, this is really convenient to use, and this provides us with a nice errors when we forgot to add something. So while I'm here, let's configure the ReScript and safe. So we use ReScript and safe actually in all our projects for both client and server side, because this is convenient. And yeah, so I've added it here, and also now we add it to the client. Remove this huge example, and let's keep only API URL. So we need to also recompile because we added a new dependency, and also we need to reload the window just in case it doesn't fetch the env safe to the IDE. So now it complains because the documentation looks like outdated. So we have what we have here. We create our environment safe, then we say that we want to get an API URL environment from the end safe, and this is going to be a string which is URL, and the fallback, let's say it's going to be localhost 3000. So we don't need to add it here. Let's remove it from here, and we have this API URL which is string typed correctly, so we are type safe, runtime safe, and ready to run the script and see that it works. And for example, if we didn't have this def fallback, we would run into an issue saying that you have missing environment variables, and it will list all the environment variables that you don't have, which is nice and really super to debug when something went wrong when you run your application. So this is it. We've created a separate client and server files, and what's nice here, it's like let's hide the terminal and always forget the shortcut. Okay, managed to do this. So just wanted to show you like how you can usually see a demo on trpc or RPC website where they have a client contract server open on every site. And for example, what if we want to change, and instead of sending the fields using JSON, we can actually change it to have a get method, and since get can have a body, we can change these variables to be sent as a query, and everything compiles and everything works. So we can change the structure of our transport without breaking anything on our client or server implementations, which is amazing. But for example, what if we say that we want to add a new field. For example, we want to immediately say whether we want to have our post public or not, which is also going to be a query and boolean. Like we don't need to curse a string or something like this, it's done automatically. And now, after I save and reload the window because I don't see any validation errors. And the reason why I don't see any validation errors is because we use row here, my bad. Yeah, so after I remove row, we finally have a validation error saying that you forget to send a field public. So if we add it here, we are actually not going to have any validation errors because like where is the implementation? Yeah, we don't use the field. It's a new field on the server, so it's nothing critical. But if we remove a field which is used here, we get validation error at both client and server. Like here's it where the body field doesn't exist, and here it also complains that body field doesn't exist. Also, we can change it to be an optional field, and also we have validation errors that it doesn't match the type, so we can fix it. And also we can add, for example, option get or empty. So it's like really powerful. Why does it complain? Because I didn't save. Yeah, let's write some more roads now when I did this fancy demo. Okay, I'm in fast typing mode, so I won't speak much. So I want to add one more road here because I think this video is already longer than it should be. By the way, I just remember that we still have it as a get, so let's return it to post. And let's use normal fields, not query string, remove the public. And here, let's add the get post is going to be a post, follow along with the supermon, but it's not correct entirely. So variables, it suggests us to make variables an object, but since we want to have only single field as a variable, we can just directly make it a string without making a user to send an object when they call the post. And it's not going to be a field, it's going to be a param because we want to send an ID as a part of the URL. And also we want to have a single response. And also let's yeah, as a response we can also, instead of having different responses, we can have a single response with status 200 and make it a union here. It's another way to use ReScript schema, and the union will have either a post schema, which is going to be a post wrapped in some, or actually a overcomplicated thing it can be. I know it's right. It's right. Or otherwise, I really overcomplicate things. Forgotten my own library. It can be done much simpler. So we simply either send null, or we send a post schema, and it means that we either found it or not. Like we could also do it this way, like returning a fancy variant, but I think option is fine here because we have a variant in this case. So we got our get post. I see some error on the client because I removed the public field here. And now like I use fetch, but actually there is when we do multiple calls, there is also this REST client way where you can pass a base URL. Also you can pass a fetcher and JSON query, like the way how the query string is decoded here, and then you can use this client to call a contract with all the data pre-configured. So yeah, feature now goes here. So this is going to be create post response, and also with the same client create post response, and with the same client we do the get post. And as I said before, we don't want to like sending an object here, not nice, so let's just send a string, and we want to get 0 post. Let's actually immediately log this. Post 0 like this, and post 1 like this. So our client is, I think, done. Not much to show here. Let's remove this and see that it doesn't work because this not implemented. So this route not implemented. We get an error about this, and this is time to implement this. And let's add it exactly under the create post. So since our post ID is an index of our mocked post, so we can simply use it as like to get an item by index. And why does it complain? It complains because we can directly return this. It's not a result, it's an option here. Nice. And also, yeah, you can see that post ID, like it's not convenient that like you want to send it as a string, but on our side it's an int. But so we can solve this in our schema. Not like there is no out of the box way to transform this, but we can add a parser of a schema int string okay, like this. So I want to have this ID be sent as a string in our transport level layer, but when we use the post, it actually, I also need to change it here, it's treated to be an int, and so if it's int we simply return it, and if it's not we shows it invalid int ID. I think it's fine. And also we need to add a serializer here, which is in American English spelling. Yeah, transform it like this. So now everywhere where we use it, we don't need to transform into string. Also, we don't need to transform string to int, and it's string here, but we can change it also in our contracts to expect ID to be an int. So now I think everywhere, yeah, and we can also change it when we call this get post route. Now we are safe and we have a convenient API to build a REST API. So let's take a look a single time at our get post implementation, and this is super simple, because like if you ever build a server API with ReScript, there are a really bunch, like huge number of lines to convert the request body to data you need to validate it. Then you need to do the same when you do a response. Here you don't need to do this. And now to see that it works, we need to restart the server, take a look at the error, and yeah, and we have an error that an optional string is not supported, and that sucks. So actually it should be supported. I'll do a patch to support it, but in meantime let's, where it is, it's in the contract. So in the meantime let's still change it to union, as I try to do this in the beginning, and do a little bit of advanced ReScript schema stuff. So let's see. I needed to add it here, and now I think it should run. So, and what's interesting here, actually I see that my webcam is frozen a little bit. Let me reload it. So maybe there's an issue. Yeah, something took all resources of my computer, so now it should be fine. Why it even failed? If you take a look at this error, it tried to generate ReScript, not ReScript schema, it tried to generate JSON schema. And why it even needs a JSON schema, this thing? The thing is that Fastify has a really cool integration with JSON schema, and it has a lot of tooling around this. So we don't use, like, it has validation of body with JSON schema and other things. We don't use this, we use the validation of the ReScript schema instead. But what we use is actually the fast-json-stringify. So every response sent, instead of using normal JSON serialize to get the JSON, it actually uses the fast-json-stringify, and it works usually 2 times faster. So out of the box, this thing will work 2 times faster than it would usually do if you written it by yourself without like some advanced configuration, writing JSON schema and other things. I think it's amazing. And also talking about JSON schema, what's cool about this? Let's go back to documentation, because I don't remember the exact name of the package. So here the ReScript Rest library, and somewhere at the end there's documentation how to write a Fastify server, and also that you can use the OpenAPI. And let's actually do this so we can see that the server running. So it's let's run the client and see that it also runs, and we can see the feature arcs, that it's built correctly, also the responses. So super nice. And let's install everything here. And so what it is, it's Swagger, a tool where we can which allows us, like, Swagger is open some sort of specification to describe your server, but actually this Fastify Swagger plugin, this is what allows us to use and generate Swagger or OpenAPI definition from our Fastify application, and it's super simple. So we get our app, and we connect a Swagger plugin. I have bindings for this included in the ReScript Rest, so it's super convenient. And we register this plugin, and we need to add some OpenAPI config, which is required, and required is info, and required is OpenAPI version. Let's use the latest one. And why does it complain? Why does it complain? I don't know. Let's remove this. For some reason, it doesn't really help me with autocomplete. Okay, let's try to debug this and install another my library. OpenAPI. Connected. And I think, yeah, now it starts working. So I didn't know this fact that you need to have a library installed in your project to make it work even if it's a dependency of another project. So there is ReScript OpenAPI used, and you also need to install it here. So we finished configuring, and what we can do with this, now we at the end, for example, our server can call console log and run OpenAPI Fastify Swagger generate, and let's see what we'll get when we run the server. We get OpenAPI schema for our server, which is nice. But what do we do with this? It's a good question. So this is not super interesting to just simply log this. So let's instead connect this color integration. Also need to add Fastify. So this is a Fastify plugin system, which is super flexible, and this app object, even though there are a lot of integration with inside of this road handler, this app is a pure Fastify instance, so you can bind to it however you want. I think it's nice, and I don't remember what I should enter here, and it should be road prefix. So let's call the road reference, and now still want to add the log, so when we start this, can click on it properly. Yeah, so we can see that get route not found, but if we go to reference, or let's even do this post 1, yeah, we get null, and if we do post 0, we get null for some reason. Because we didn't create the post here. So if you do reference, so it's copy paste in case I did an error, and let's do localhost 3000 reference. Yeah, now it works, and we get a really beautiful our API documentation. So there's a description of our post, create a new post, body, and like also all of these things, and we can play around with this. So for example, we can test this post, like create post request. Let's create something with hi body, send it, and we received our post back. So now if we run this and pass an ID 0, we'll be able to get this pose back. And what's cool, there is also an OpenAPI client, so you can automatically generate you can have a nice UI to call your OpenAPI. Also, you can generate a nice client for any language to call this thing, and yeah, it's really powerful to have this OpenAPI integration. So you can have your server written in ReScript and have code generated to interact with the server for any other language. I think this is amazing, and actually there are plans to build similar tool so we can get any OpenAPI schema and have this contract file automatically generated. But this is only in plans, and if you really want this, go to ReScript Rest, leave a star, and create a bunch of issues saying please do this thing, because I have quite many things to do with ReScript schema library, and yeah, I hope I'll finish it at some point of my life. So here I think we are done with showing many cool features, and I actually promised you to also show how we would create tests, but this is really already taken quite long. So I would simply say that for server tests, I would recommend using this ReScript App. It's quite simple. For browser tests, I personally like ReScript Retest. There are bindings out there on the internet, and to test all this like roads or something like this, there is a nice Fastify inject function where you can inject some params, like for example how it would be called with fetch. So you can imitate a fetch call of your application using this Fastify inject, and like you can run it in your test framework. Actually, you can choose any test framework for this. And yeah, I just want to show you one more thing. How I call this. So I have just a wrapper of this inject function in the ReScript Rest library, which I use for all the testing I have here. So I call inject with fetch arguments user provided, and then I return this okay sorry. So I made a wrapper which accepts this arguments of the API feature of the ReScript Rest, and which returns a response of the API fetch, and under the hood it calls the Fastify inject, and then this inject function is called inside of the REST client I have. So this way I have really nice type-safe tests whenever I don't need to test something going outside of the types. For example, if I want to test how my server handles invalid data, I use another approach, but here I think it's quite nice. I think you can, yeah. So you simply create an application with Fastify, define your roads, then you define some local client, possibly with some additional tests, for example, of the internal implementation, how it's going to be transferred via HTTP, and then you can call app inject to imitate a call to your Fastify application. So, and after you've done a call, you can test that it returned you the correct data. So I think it's super convenient and nice. And whew, this was a lot. This is whole stack. This is my first video to feature the tool, and actually multiple tools. Like here in this video, we've covered, I think, 6 tools I've built. And yeah, in the future, I'm going to record more videos, going into like have some shorter versions or going deeper in the details of each library. Also, maybe some videos of just writing some ReScript code. If you're interested, subscribe to this YouTube channel, which is not created at the moment of recording this video. And also like follow me on Twitter and other places. And yeah, have a good building.